Cool, I'm going to pick up where I left off with the quadratics unit test review packet. I did 1 through 3 in an earlier video. Start with number 4. In class we identified the h and the k, the 0, 3, and I believe we chose a point together, 2, 7. The big deal about this vertex form and where the element that we have to go looking for is the a. I have an x, a y, an h, and a k, so I have everything that I can put into the equation to solve for a. So y is equal to my unknown a times the x value minus the h squared plus the k. 7 equals, this is going to be 2 squared, 4a, 2 to the second power is my 4, bring my a over, just writing it the way that we like to represent these. If I take 3 away from both sides, I'm with 4 equals 4a. That gives me an a value of 1. Now, in order to finish writing the equation, I need to put it into my y. Well, actually, we've got f of x. We're going to use function notation. F of x equals 1 times the quantity x minus h squared plus k. Now, I do believe I can write this simpler. The fact of the matter is that the 1 doesn't need to be written. It's assumed. And x minus 0 is redundant as well. So, truly, my function is f of x equals x squared plus 3. Easy money. Parent function, x squared, just slid 2 units up the y-axis. The second problem for vertex form, we identified the h and the k and the x and y in class again. I'm going to set it up to solve for a. Negative 9 equals a times x minus negative 4, or x plus 4 squared plus k, which is a negative 5. Negative 9 equals a times the quantity 2 squared minus 5. If I add 5 to both sides, I'm going to wind up with negative 4 equals a times 2 squared, or 4a. In this case, the a value is going to be negative 1. Divide by 4, divide by 4, a is negative 1. So let me go back and put it into my vertex form. Again, function notation, f of x equals negative, I don't need the 1, I'm going to open my parentheses, x minus h, so x plus 4 squared minus 5. Let me write that a little. F of x equals negative quantity x plus 4 squared minus 5. There you go. Now, moving along, I need to simplify the radical expressions down here. I'm always looking for the perfect square factor to pull out of each of these radical expressions, and I always want the largest ones. Of course, I'm going to talk through this quickly because I've thought about these problems and you might have played around with other things, but the largest perfect square factor in square of 200 is 100, so this is 10 square roots of 2. Number 7 is going to be, I know that the square root of 49 is 7 and the square root of 169 is 13. Simplifies to negative 7/13. I can put my negative sign outside the fraction if I wanted to. When we get to our radical expressions with variables to a particular power, again, we're going to deal with the numerical values. I'm going to actually give myself a nice large radical sign to deal with. My numerical value of 60, I'm going to look for perfect square factors of 60. What do I got? 4 times 15. 4, no, it'd be 6 times. Yeah, 4 times 15. 4 is my perfect square. I think about 15. Is there a larger perfect square? Is there a factor of 15 that's a perfect square? And there isn't. I'm going to write r to the third as r squared times r to the first. I'm going to write s squared the same way and t to the fourth the same way. If you recall, we talked about the powers needing to be even in order to take the square roots of them. I'm going to put a radical here. I'm going to start by taking the square root of 4 out from under the radical and putting that out here as 2. I'm going to leave the 15 in. I'm going to take the square root of r squared and bring that out as r. And then I'm going to leave the r to the first in. I'm going to take, because it's not a perfect square, I'm going to take the square of s out as just s. I'm going to take the square of t out as t squared, because t squared plus t squared, t squared times t squared is t to the 2 plus 2, or 4. So this is going to be t squared, and that came out. Now, my expression looks really silly because I squished everything up right there. But I can clean it up. 2r s t squared radical 15r. Now, I'm going to simply multiply my negative 3 times 2 together in number 9 and get negative 6. And then I'm going to look at what I have under the radical here. The radical 3 times radical 15 can be written as radical 3 times 15. So negative 6 times radical 45. I see where I'm going with this. 45 has a perfect square factor that is 9. So I'm going to do negative 6. Pull out radical 9 is 3 and leave 5 under. Negative 6 times 3. I'm running out of room here. I'm just going to erase it. It's going to be negative 18. Simplify it right there. Negative 18 radical 5. I think I'm going to stop here. This video is getting a little long. I'll be back at you with more problems.